Hello, today we are discussing mathematical operation on continuous time and discrete time signal, and the operation which we are discussing is time shifting. It is operation on a time, so we can call it transformation of independent variable, that is time. Let's start. Time shifting of a signal is obtained by time delay and time advance operation. That means there are two time shifting operation, time delay and time advance. Let x of t is a continuous time signal. Then its time delay is denoted as x of t minus t1. That means your signal get delayed by t1 time unit. Similarly, time advance is denoted by x of t plus t1. Your signal get delayed by time unit t1. T1 is a constant time unit. Now, delaying the original signal by t1 time unit on a time axis means what? Shifting the original signal towards the right by t1 time unit on a time axis. And advancing the original signal by t1 time unit means shifting the original signal towards left by t1 time unit on a time axis. That means delaying shifting the original signal towards right by t1 time unit, and advancing means shifting the original signal towards left by t1 time unit. Now, where we are using this time shifting operation and where we face this shifted version of the original signal. In the application, radar, satellite communication, seismic signal processing, sonar application. Here, several receivers are located at different locations. So our observed or required signal being transmitted through the different medium, and due to the propagation time to travel the signal up to the different receivers may receive this signal in a time shifted version of original transmitted signal. Some receiver may receive the signal at particular time, then other receiver receive with some delayed time. The same signal get received at different receiver with time shifted mode. And this is the application of time shifting operation. Now let's solve one example. Let this x of t is the signal. This is the signal x of t. We want to perform time delay operation. So same process. First, mark original x of t as a x of t dash. So this time axis become t dash. Just for our convenience, we are differentiating this with the original signal and the delayed signal. Original signal time axis, we are marking it as a t dash. Now, we want to convert this t dash to the delayed version, suppose t minus 2. We want to delay the original signal by 2 time unit. So what is t? T is t dash plus t. So t is equal to t dash plus t. How to do that? Same process you have to follow which we did for time reversing. T dash original time axis and t is the time axis in a delayed version t minus 2. Now we'll calculate t, which is the time axis in a delayed version. T is t dash plus 2. When t dash is minus 2, what is t? Minus 2 plus 2, 0. So whatever the amplitude of the signal at t dash is equal to minus 2 will get transferred to t is equal to 2 in a t is equal to 0 in a original sequence. Now t dash is equal to minus 1, t is equal to minus 1 plus 2, 1. So whatever the amplitude at t dash is equal to minus 1 will get transferred to t is equal to 1 in a delayed sequence. T dash is 0, t becomes 2. So whatever the amplitude at t dash is equal to 0 will get transferred to t is equal to 2 in a delayed sequence. Similarly, t dash is 1, t becomes 3. So I told you that to get the delayed version, we have to shift the original sequence towards the right by 2 time unit. Here we want t minus 2, so 2 time unit. So will shift towards the right by 2 time unit. You can cross verify your answers using this table. T dash is equal to minus 2, T is equal to 0. T dash is equal to minus 2 amplitude get shift to the T is equal to 0. Similarly, T dash is equal to minus 1 amplitude get shift to the T is equal to 1. So you can check here, this point gets shifted by 2 time units towards the right. This point T dash is equal to minus 1 gets shifted by 2 time unit, 1 time unit and 2 to the right. Similarly, T is equal to 0, T dash is equal to 0 time is shifted to 2 time unit, means 1 time unit and 2, means this 1 amplitude gets shifted to the T is equal to 2. And using this table, you can cross verify your answer. This table is required just to cross verify. Otherwise, you can directly shift your original sequence towards right by given time unit, by which time unit you want to delay the sequence. This is for the continuous time signal. Similarly, you can do for the discrete time signal. Same logic, x of n, we will mark it as a x of n dash. So time axis, instead of n, we will mark it n dash. We can make a table. N dash, we want to shift the signal by 2 time units. So n dash we want to convert to the n minus 2. So what is n? N is n dash plus 2. So n dash is equal to minus 3. What is your n? Minus 3 plus 2 minus 1. Means what? Whatever the amplitude at n dash is equal to minus 3 will shift to n is equal to minus 1. So this n dash minus 3 gets shifted to n is equal to minus 1. So you can check here, this n dash at n dash is equal to minus 3 shifted towards the right by 2 time unit, 1 time unit, 2 time unit. So here at n is equal to minus 1. Similarly, n dash is equal to minus 2 will shift towards the right by 2 time unit. 1, 2 means it will come at n is equal to 0. You can check here using this formula. N dash is equal to minus 2. So n becomes 0. So n dash is equal to minus 2 amplitude gets shifted to n is equal to 0. Similarly, n dash is equal to minus 1 amplitude gets shifted to n is equal to 1. 1 time unit, 2 time unit. Shift towards the right by 1 time unit. Similarly, now you can tell n dash is equal to 1. It gets shifted to n is equal to 3. N dash is equal to 2 gets shifted to n is equal to 4. N dash is equal to 3 amplitude gets shifted to us n is equal to 5. So this whole sequence gets shifted towards the right by 2 time unit. So this is the shifting operation or delayed operation of a sequence for continuous time and discrete time both. Now for same signal we will do advancing operation. That means we will form x of t plus 2. So this is your x of t. We want to obtain x of t plus 2. So we'll mark the original signal as a x of t dash. So time axis become t dash and we can make a table. Now this t dash we want to convert to t plus 2. So t becomes t dash minus 2. Then for each value of t dash we'll calculate what is t. That means whatever the amplitude at that t dash will shift it to the whatever the t we get in a x of t plus 2 sequence. Or the simplest way, whatever I told you, in advancing, the original signal will shift towards the left by particular time unit. That means for x of t plus 2, this is the original sequence and you are shifting this towards the right by towards the left by 2 time unit. You can check this and you can cross verify your answer using this table. See, t dash is equal to minus 2 get shifted to t is equal to minus 4. T dash is equal to minus 1 get shifted to t is equal to 3 minus 3. So like this, t dash is equal to 1 get shifted to t is equal to minus 1. the whole sequence gets shifted towards the left by 2 time unit. In a time delay, the whole sequence gets shifted towards the right by 2 time unit. Similarly, for discrete time signal, this is your x of n, original x of n, we'll mark it as x of n dash, time axis becomes n dash. We can make a table. This n dash we want to shift to n plus 2, advancing operation. So calculate this n becomes n dash minus 2. Then for each value of n dash, you can calculate your n in a advanced signal. So advanced signal is x of n plus 2, and you can directly do the original sequence gets shifted towards left by 2 time unit. Means what? This n dash is equal to minus 3 will get shift towards 2 time unit means minus 4 minus 5. And you can verify here. N dash is equal to minus 3 will get shift towards n is equal to minus 5. So this original sequence, see how it will get shift towards time unit 2 towards left, minus 2 by 2 time unit 1 and 2, like this. Each sample will shift towards left by 2 time unit because we are advancing the signal by 2 time unit n plus 2. So this is the advanced version of the same signal, our original signal. This is the advanced version by 2 time unit. So, to delay the signal, we'll shift the entire signal towards right by particular time unit. For advance the signal, we'll shift the original signal towards left by particular time unit. How to remember this? Just analogy. Suppose to reach at particular place from my house, I have to start at 10 o'clock and I will reach there in 1 hour at 11 o'clock. Now, suppose instead of 10 o'clock, I started at 9 o'clock. So, by default, I should reach there 1 hour before. That means at 10 o'clock. The entire time slot gets shifted towards left on a time axis. Now, suppose I started at 10 o'clock, but due to traffic, I delayed by 10 minutes. So my 10 minutes get waste in the traffic. So I will reach there at 11:10. So entire time slot gets shifted towards right. That means delay. I reach with the 10 minutes delay. And in case of advance, when I started 1 hour advance, I reached there 1 hour advance. So like this, you can remember this analogy where to shift the signal. In a delay operation, we are shifting towards right. We delay that time unit. And in case of advance, we'll shift the signal towards left. We start earlier. That's why towards left. So this is about time shifting operation. Thank you.